All right, everybody. Cool. So let's start off by answering the Mahia. So I'm just going to move.
What's wrong?
All right, let's focus and get the work done. All right. So first off, we are thinking about our Mahia question. Our Mahia question was looking at balanced. I know. And unbalanced. So I'm just going to create a list. All right. If you don't have an answer in your book, you should be copying down what I have written, and those masks should be going over the noses. Oh, thank you. All right. I'm going to wait till the chit-chat's done. Now, you guys are going to determine whether or not I am going to be making a seating plan. If you can manage yourself, then we won't need a seating plan, but if you can't, then we're going to make one. So, show me that you can manage yourself. All right. So, for balanced motions, we have stationary. And we have constant speed. For my unbalanced forces, we have acceleration and deceleration. Right, the people that are having their backs towards the projector, I need to be seeing you turning and writing those answers. I'm very concerned by the fact that I haven't seen your heads turn. There we go. All right. For acceleration, the next question was which of the forces in that horizontal plane is greater? So for acceleration, it would be thrust. So thrust is greater than your friction. So you have a lot of push from that engine. It's making you go really, really fast. For deceleration, it's the opposite. Friction is greater than your thrust. So I'll leave it up there for a moment just to make sure you guys have a chance to copy it down if you don't have the right answer. You can't go on the first half hour. It's gone. Oh, sorry about that. I don't know why I keep having that weird pop up.
It used to do that with the other teacher that was here too. So
Yeah.
I think it's the connection. Is that what I did?
All right. Can I move it?
No.
Alrighty, cool. Let's move on then. It's still frozen on the screen. Let me unfreeze it. There you go. Alrighty. So for today's learning intention, what we're going to do is revision on what is energy and how it transforms. So this is stuff that you guys did during your remote learning last week, and I just want to recap it because I'm mindful some people had different successes and challenges with that remote learning. So I want to make sure we're all on an even playing field, and so we are doing some of that revision. Sound good so far? All right, shall I keep going? Okay. So, lesson plan for today is, first thing that we're going to do is we're going to finish up that task from Monday, which is the forces in motion in sports. I'll wait till you guys are done. Yeah. I'll wait till you guys are done. Ready to learn? I know it's last period. I know you guys are tired. But I still expect you guys to engage. Alrighty. So, we will do the forces and motion activity. We'll wrap that up from Monday's lesson. Then we'll have some notes on what is energy. And we'll do a Kahoot to reinforce that information. We have a fun activity, lolly break, that I want to do with you guys, but you will find that out when we do that. Are we done chatting? You know what? I'm not gonna. Bees are coming out.
How many?
Yeah.
How many?
Depends how long you guys want to keep trying. Alright, after that we're going to be doing some notes on energy transformations. I have a video to show you guys about how we can use gravity to create light, and then we'll wrap up with some science world work. On our checklist today, we are looking at number 10 and number 11. Now, I know there's some new students, and I forgot to copy some more. I don't know how many I have right now. Let's see. Oh, actually, I got a couple. I have 3 more, so I can give that to the students. All right, so off the checklist, we are taking off number 10 and 11. So, and you should be taking off number 10 and number 11. Number 10 and number 11 are being ticked off today. I can explain conservation of energy, and I can also state how energy is transformed through the different types. Now, I know there's some new people to our class, so I'll just pass out some more checklists. Yep. I need to press more than the last 2 I have. I don't have any color right now. Well, you got to think about then who your friends are, and if you're, yeah, because they're the ones that are taking them. Alrighty. So, gentlemen, leave the bag here. All right, you ready? Wait till I give this instruction. All right, masks need to go over the nose. All right, what I want us to do is finish the activity that we started on Monday, which is that Google slide. So let me show you where we're going to go get that. So I want you to go back to lesson number 6B on Google Classroom. All right, so if we look, can we all look to my board, especially those that are sitting towards their backs to the board? And I'm not really liking that kind of arrangement that you're having the back to me. All right. Ready? So I want you to go and click on the Google Slides Force and Motion in Sports. You are going to find a video on YouTube of a short sports clip and insert it into the Google Slides. And then you will write a paragraph explaining what you see with that sports video, and link it into your knowledge about forces and about motion. Now, with that created by, you need to write down your name. You are allowed to work in pairs. So if you're working in a pair, write both of your names down. All right? Now, while you're working, call me over once you're done so I can check it and give you feedback. I will give you a sticker for getting this work done. So that's the other reason why you should call me over. Are we okay with those instructions so far? All right, so I'll give you guys probably, let's see, maybe 10 or 15 minutes to work on this. So 2:40, and then we'll move on. All right, so what I need you guys to do now is close your devices because the next task does not require devices. If you have not finished writing your paragraph, you can finish that at home, and you can collect your sticker in your next lesson if it's done. You will need it for the Kahoot. I think after these notes, okay? All right, so I want you guys to close your devices and open up your science notebooks.
Yeah.
So don't open up the science textbook, it's a science notebook. So you can write notes. I should see those devices getting closed and your notebook ready. Huh? All right, so we are going to our document camera, which keeps crashing on me. Restart it. Okay, then you can leave it open. Oh. I'm going to do the notes. You can go after I do the notes. All right. So, what I want you guys to do is open up your notebooks, and we're going to do some revision notes on energy. So with that energy, once again, I think we should do a mind map because I think it's really good for us to visualize how this information interacts together. And yeah, I think that's what I want to say so far. Okay, so first thing in our mind map is we need to think about what is energy. So energy is the ability to do work. And I'm going to make that my main thought bubble because we're trying to think about energy as the main idea. All right? You know the mask? There we go. All right, so you guys need to make sure that you're writing down what I have on the board. I should see lots of little pencils moving. All right. Now, there are two types of energy that we are thinking about. We're thinking about, first off, the active energy. Active energy is detectable, so we can see it. We can feel it. And since it's detectable, the way we see and feel it is when particles or waves move. And I'm going to do a circle around that because it's another key idea. Detectable, when particles or waves move. Can we think of some examples of energy that are active, that we notice, that we can feel and see? Hand movement, so that's a type of kinetic energy. So kinetic. That's movement that you guys described to me. If I move faster, do you think I have more energy? Yeah.
What?
If I move faster, do I have more energy?
Yes.
If I was a heavier object, so let's say we have a car versus a truck and they're both moving at the same amount of pace, which one do you think has more energy? The car or the truck? Would it be worse to be hit by the car or be hit by the truck? The truck. So which one has more energy? The truck. So the more massive something is, the more energy it has. All right. Some other ones. What are some other active forms of energy? How about heat? Heat is a form of energy. You know what's another form of energy? Light. And with light, that can break down into two examples. We have the electromagnetic spectrum, so electromagnetic energy, like X-rays. And we also have solar energy. That's why we think about solar power. There's also electrical, such as electricity, when we're talking about current. So like what's going on with my computer. And there's one more, and that is sound. Sound is a form of energy. You can feel it when you're like touching a speaker and it's like got a good bass. You can feel those vibrations. All right. The other example of energy that we're thinking about is potential energy. Potential, which is also known as stored. So we can't detect it unless it becomes active. Until it becomes active. So we need to think about some examples. Oops, shouldn't have done a bubble. What are some examples of potential energy? Does anyone know? Potential energy. You guys had lunch? What do you think there's energy in that lunch?
No. Yes.
What type of classification would we put?
13.
Food. Chemical. Chemical. So that's, for example, food. Can you think of another form of chemical energy?
Food poisoning.
Think about what you put into cars.
Engine.
The engine, but what do you make to make the car work? Fuel. So fuel is another type of chemical energy. All right. Some other examples are gravitational. So when I have something and I'm holding it in the air, it has the potential to fall, doesn't it? So do you think if I have my mouse here, is it going to do more damage to the mouse if I drop it from here or if I drop it from down here? From up higher. So higher has more energy. So we should write that down too. All right. There's a couple of other ones that we should be writing down. There are mechanical. There are nuclear. Like in The Simpsons, they work at the nuclear power plant. You've also heard of nuclear energy. There is elastic. Do you guys know what elastic energy is?
Yes.
It's like if I take a rubber band and I pull it back, that is elastic energy. And then if I release it, it then goes into kinetic. All right, and then the last example, again, is also electrical, but it's in the form of a battery.
Battery. Yeah.
All right? Those are all the notes for the first chunk. All right, I'll leave that up, and then we're going to be able to play a Kahoot next. Hold on a sec. All right, types of energy is the quiz. Fix the mess. All right, what type of energy is produced when objects vibrate? Think about when you touch a speaker, you can feel.
Sound. Oh yeah, that's gravity.
There we go. Sound. Great work, guys. All right, next question. All right, what is the main type of energy in the image of the surfer? So kinetic, elastic, sound, or heat from the surfer. Kinetic, because they're moving. Moving. Ooh. All right, which of the following is an active form of energy?
Gravity.
Active.
Chemicals.
Oh no.
Heat.
Oh no! It is heat! Only one person got that. Everything else is active. All right, what type of energy is stored in the cereal?
It is light. On it, it's this.
Oh, sorry, kiddos. Coming back. Chemical, good, 100%. All right, X-rays are an example of what type of energy? Mask on.
It's
Light, very good. All right, objects that are high up, what type of energy would it have? Gravitational, good. All right. Which one is potential? Also known as stored energy. Wanna come up in? Ooh. Elastic is the only stored one. Everything else there is active. All right. What type of energy is due to the movement of atoms? This one's a little bit tricky. I haven't quite covered it. Heat energy, good. Hotter something is, the faster it will vibrate. All right. The movement of electrically charged particles relates to what type of energy?
light.
Electrical, good, perfect. Alrighty. Last question. An ultrasound. So when someone's pregnant and they go and get an ultrasound done, what type of energy is that? Light energy. Trick question there. All right, top three. You can come up and grab your sibling. Top three, you can come up and get yourself a prize. Just one lolly or... I thought, you know, we played Kahoot and some people obviously won and some people didn't win. And I thought it would be nice if the losers, as a consolation prize, and we'll get a fruit first. Now, we're not supposed to be eating inside the science room. We're going. We're going All right. We'll be going outside and you'll be getting a fruit burst.
And we have to practice your one.
So let's get a little bit of fresh air.
Yes, please.
All right, so just to wrap up with this activity, we need to think about what fruit bursts are, which is a form of chemical energy. Now, one fruit burst gives you 85 kilojoules of energy. So if you were to jog, and you were jogging at 25 kilojoules per every minute, so you burnt 25 kilojoules, in a minute of jogging, you would burn 25 kilojoules. So the lolly is representing the chemical energy, whereas the jogging is representing the kinetic energy. You would need to jog for 3 minutes and 24 seconds to burn off the energy that you got, or convert that energy from chemical into kinetic. So that's where we left off for today's lesson, and that activity does lead into energy transformations. So we'll finish that recap. We were just revising what energy was, and in our next lesson we'll talk about transformation. By the end of this lesson, we actually can't tick off any of the success criteria because we haven't finished it, but we have gotten a start on it because we are thinking about that energy conformation. Sorry, that energy, what is energy, and also the different types.